let's go ahead and get going here. Inverse functions. The idea of inverse in math, when you talk about functions, is something that undoes something else. Okay? So the idea we've got here is if I asked Luis, for instance, if I asked Luis, how do I get from this spot to Burger King because I'm hungry and I want a Whopper? And he gives me directions and I follow the directions, I will get to Burger King. What happens, though, if I follow those directions in reverse once I'm at Burger King? I will end up back where I started, right? So the original function, so to speak, directions, sent me to Burger King. Doing the opposite of them, doing them backwards in reverse, send me back to where I started. That's the concept of inverse functions. Okay? So f of a equals b, if f of a equals b, then a function g of x is an inverse of f if g of b equals a. So here's the idea. Originally, a is the input and b is the output. The g function then takes that output b and sends it back to a. You see that example? So the first thing sent me to B, Burger King. The second thing sent me back to A, where I am now. Okay. So the inverse of f of x is typically notated with f and then a -1 as a superscript. It's not an exponent, so be careful there. It looks like an exponent, but that means the inverse of the function f. And it's read f inverse of x. So equivalently, you could say the same thing as we set up here. If f takes a and sends it to b, the inverse will take the b and send it back to a. So they're just undoing each other. Okay, just like how we solve equations, we see, oh, they're adding, I need to subtract. We call those actually inverse operations. Here we're talking about inverse functions. It's the same kind of concept. Oh, there's a blank. That's another one I have to fix. Okay. So here's our information. F sends 2 to 8. It sends -3 to 4. It sends 5 to 12. And it sends 7 to -1. So here's the question. What would f inverse of 8 be? 2, because if f sent 2 to 8, the inverse sends 8 back to 2. Right? What would f inverse of 4 equal? -3, because -3 was sent to 4, the inverse sends it back. What would f inverse of -1 be equal to? 7. Right? Make sense? So it's just undoing what was just done. It's a way we do cancellation with functions. Okay, so we got these three. I skipped the middle one just so you didn't just start reading across the line. But anyway. All right, so notice this information could be given in a table, right? 2 was sent to 8. -3 was sent to 4, 5 was sent to 12, 7 was sent to -1. Same information, just in a table. Look at what happens when we write the inverse. When we write the inverse, what do you notice? What's the difference? So 8 gets sent to 2, 4 gets sent to -3, and so on. What's the difference between these two tables? Perfect. Say that a little bit louder. The x and y switch, right? The x and y coordinates switch spots. Because all the outputs become the inputs and all the inputs become the outputs. That's important. Okay? So, this is why it's important. The function f of x equals 2 to the x power has a domain, x values, -infinity to +infinity. Yeah. Right? It has a range, and you don't know this, but I mean, you may know it, but we haven't talked about it yet, but I'm telling you, it has a range of 0 to infinity. That's the range, the y values. What would you expect the domain and range of the inverse to be? What do you think? Think about what we just said about the table, right? X and Y switch. Domain is the x's, range is the y's. Yeah. So what would the new domain of the inverse be, do you think? Infinity. Somebody said it.
0 negative.
0 to -infinity.
It's going to be u on the side, right?
Or wait, not -infinity. Infinity, sorry. Yeah. Does that make sense? Because the old y values become the new x values in the inverse. And then what would the range be?
Negative infinity to infinity.
Yeah, negative infinity to infinity, because the original x values become the new y values, right? They just switch. That's why I showed you the table. So we got that, x and y switch, but the same thing, it happens for all the values, right? Not just the table, it happens for every value in the function.
Is that simple to show on graph?
We're going to get to that, but yeah, you're going to see it. There's a definite pattern of what happens with those. Okay. So a function f of t is given in the as a table below, showing distance in miles that a car traveled in t minutes. Can you first of all find f inverse of 70?
90.
Yep. So you start here, and it's sending you back to here, right? So f inverse of 70 is 90. Now, let's try to interpret that. What does that actually mean? Well, they gave us the 70, which is miles. Our output was 90, which is, so what is that telling us? If I need to drive 70 miles, it's going to take me 90 minutes. We're going slow, or at least not super fast. Okay? So that's the idea there. Does that make sense? All right. This is the same. Are we okay with that concept? It's the same thing, just different numbers. All right. So here's our graph. Let's see if we can do this with a graph now. So we did it with a table. So first of all, g of 3. That's what we've been doing since last week. So how do I find the value for g of 3?
Go over 3.
3 is my input value. It's the next value. I go over 3 and I look up and I see g of 3 is 1. Everybody okay with that? That's from before. Now, today, we do this. G inverse of 3. What does that mean? That means the output is 3, correct? Which the output is the y value. So now we're looking right here at the y value, and we're saying, okay, if the output is 3, what was the input? 5. So g inverse of 3 equals 5. Right? So it's really helpful to think input, output. Input is the x's, output is the y's. So when you do that inverse, it's starting with the output and going back to the input. Okay? How about this one? Anybody do it for us? First of all, g inverse of 1.
Yeah. 3.
We start with the 1. Oh, okay. A balloon sitting there. Okay, start over here. Yeah, 3. X is 3 when y is 1. How about the second one? G inverse of, whoops, my mask just fell down. Don't look.
It's his face.
It's my face. Hideous. Look away. Okay, anyway. Some of you are old enough will know what that's from. But anyway, G inverse of 4. So what do we have to look at?
4 on the y.
Well, we go on y. Now it's not exact, but we can kind of estimate. Where is it in the relationship there? Looks like 5.5.
5.48.
5.48326. That's kind of how it was on the computer. So I would say 5.5 is close enough. Okay. But does that make sense? All right. Properties of inverses. In order for a function to have an inverse, it must be a one-to-one function. Do you remember what that meant from, that was section 1.1. We talked about one-to-one functions. Anybody remember? Each input has its own unique output. So every output is different. There's no way to get the same output from different inputs. That's like you go to a store and everything has its own price. There are no duplicate prices. Okay, that's one-to-one. The input and the output are a one-to-one match. So finding inverses of one-to-one functions. Here's the steps we would go through to find the inverses. First, instead of writing f of x, it's easier to do the algebra if we just write y equals whatever. And I'll put all these up here so you can copy them. Second, we interchange the x's and the y's. So remember that what we did on the table, or what we figured out from the table, the x's and the y's switch? That happens in the equation too. So we just replace all the x's with y's, replace all the y's with x's. Then we do algebra to get the y by itself. To solve for y, we call it. I think the result is the inverse. So those 3 steps, that's how you find the inverse. Now, again, it has to be a one-to-one function before you can do this, because otherwise you can get a lot of crazy stuff happening. But if it's a one-to-one function, we can go through this process, and that's how we find the inverse. Okay, we're good? Everybody got it? All right, let's do an example. First thing, we always want to check, if we can, if it's a one-to-one function. What shape is this? Do we know? I think we talked about it last week, but we talked about a lot of things last week. This is a line, right?
Yeah.
It's not a horizontal line, not a vertical line, but it is a line. And do you remember the test we had to use for lines or for any shape to tell if it was one-to-one? So this one looks kind of, we'll just say it looks kind of like that. So the first thing was a vertical line test told us, yes, this is a function. Secondly, the horizontal line test told us this is a one-to-one function. So yes, a line, unless it's horizontal or vertical, is a one-to-one function. Okay? So I don't need to really see the line. I just need to have it know that it's a one-to-one function. So here's what we did. First step, we just write y equals 5x plus 8, because again, it's easier than writing the f of x. So that's step number 1. Step number 2, what does it say?
You change the x's and the
Yeah,
y's.
so this is now going to say x instead of y equals 5 times y instead of x plus 8. That's the only, we just switch the x's to y's and switch the y's to x's. So the first 2 steps are really easy. Now we have to do the algebra. We have to try and get this y by itself. So what's the first thing we need to get rid of if we're trying to get the y by itself? Not the 5.
8.
We get rid of the outer layers first. We're going to get rid of this 8. Subtract the 8. So now we have x minus 8. Can't do anything with it. Just leave it as x minus 8 equals 5y. Now what do we need to do to finish getting the y by itself? Divide by 5. Okay, and now the y is by itself, correct? So here's what that means. The inverse of f of x is equal to x minus 8 over 5. Now, if you think about that kind of from a common sense approach, think about what happens. What is the original function doing? Multiply by 5 and then add 8. Think about the opposite. First, I subtract 8, and then I divide by 5. You see how you're just doing the reverse? Like my directions from here to Burger King? If I do the reverse, then I get back to where I started. Okay? I don't remember how I have the answer written. Notice the answer is written in a slightly different format here, because we can put the 5 underneath each part individually. So this is like the x over 5, it's like the 8 over 5, but that's the same thing. Just a different way of writing the answer. All right, how about this one? I'll just tell you, it is one-to-one. We'd have a hard time probably drawing that one. X to the 5th is going to look kind of like this. And so what does this do to that function? If we think about our transformations, minus 3
Goes to the right.
Because is it grouped in with the x?
I don't know.
No, it's not. Because the x to the 5th is the main function. So this moves it actually down 3. And then we divide by 2, which shrinks it. Okay? Not that we care that much, but it is a one-to-one function. Just to try and review a little bit. All right. So the first step is
Y left there.
put y equals instead of the f of x. So y equals x to the 5th minus 3 over 2. Next step, interchange. I saw the motions, interchange them. So x equals y to the 5th minus 3 over 2. That's getting too close together there, isn't it? So that's separating. Now our goal is to try and get that y by itself. What's the first thing that we would do? And again, you got to kind of think of layers. Anybody have an idea?
Multiply 2, maybe.
The first thing, we have to be careful because division bars, here's the deal with division bars, they're actually grouping symbols. So this division bar really groups the top all together. So the first thing we have to peel off is this 2 on the bottom. So dividing by 2 to get rid of it, we do what? Multiply by 2. So 2x equals y to the 5th minus 3. Next,
Yeah, 3.
add the 3 to take off that layer. So plus 3. So now we have 2x plus 3 equals y to the 5th. This one we haven't specifically talked about, but we've kind of done similar to it.
You moved it to the
We
5th.
take the 5th root of both sides to cancel out that exponent of a 5. So 5th root there, 5th root there. That just cancels when those are the same. Index and exponent, they just cancel out. So we're done. So our inverse would be f inverse of x equals this right here. The 5th root of 2x plus 3. And that, again, it's those 3 steps every time. Getting cameras, I'll just get out of the way. I don't need to be famous. Just need to be out of the way. Okay. Oh, more cameras. Cameras are amazing. I mean, phones are amazing now, right? In the olden days, this is how we got the phone. Hello? And this is how far we can move. Okay, put it back. All right, we're good? So this is, again, this is just another way of writing the same thing. Don't worry about that notation. This is what I would expect from you guys. We'll get to that later. But okay. Here's where we go with the graph. Okay. So the quadratic function h of x equals x squared is not 1-to-1. If we draw it, we can see why. Because remember, it looks like this. So yes, it's a function, but not 1-to-1. Horizontal line test will fail. Find a domain on which this function is 1-to-1. So that's where we're going to start. Find a domain on which this function is 1-to-1. In other words, we want to only look at certain x values so that we don't have this problem of it being not 1-to-1. So we actually have a variety of options, but probably the easiest one is to use the y-axis and just split it right down the middle. Do we see that if I look at the left side only, it's 1-to-1? If I look at the right side only, it's 1-to-1? Does that make sense? So we're going to limit ourselves, and we're going to say, okay, let's just do this one. We're going to only look at the right-hand side. X values that are 0 or greater. Okay, do we see that that's going to make it 1-to-1 if we only look at the right-hand side? So now we do our steps. Actually, let me draw this a little bit more carefully so that when we get to the end, we can answer your question about what it looks like. So here's this, 2 would be a 4, 3 would be up here like 9. Okay. Now, find the inverse on that domain. So our domain is from 0 to infinity, right? This is our domain. So we just go through the steps. Instead of h of x, we're going to write y equals x squared. What's next?
You flip the y next.
Step 2, we switch them around. So x equals y squared. And how do we get this y by itself?
Square root.
So here's the deal. I'm going to stop here for just a second. Do you remember, and again, I don't remember if we talked about this specifically last week, when you take the square root of both sides of an equation, did we talk about the plus or minus?
Yeah.
Did
Can
we?
you do it again? Because I don't remember.
Yeah. When you take the square root of both sides of an equation, you have to put in a plus or minus in front of your answer because, for instance, if x squared equals 16 and I take the square root of both sides, I might think, oh, 4 is the only answer. But also, in the original function, isn't -4 squared also equal to 16? So to get all the answers, we have to put in a plus or minus when we take the square root of both sides. Similarly, we'd have to put in a plus or minus right here. But that's why we had to limit the domain so that we don't have to worry about this plus or minus. Okay? So what happens is, notice our domain was only positive. So what should our range be after we find the inverse? Only positive, right? So we don't have to worry about the negative. We just have the positive square root of x. And that's our inverse.
Which explains why it has to be a 1-to-1.
Yeah, because otherwise you get things messed up. So square root of x. Now, let's look at the picture. Remember what the square root of x looks like? Here's what it looks like. Right here, right here, right here, and, about right here. Okay, so inverse functions. When you graph a function and its inverse, what always happens is, I'm going to use the black for a second, it always reflects over this diagonal line, the y equals x line. And the reason it does that is because you're taking all the x values and turning them into y values, and you're taking all the y values and turning them into x values. So it just flips over that line. Okay, and that will always happen. So you'll always have some sort of shape that flex over that line. Okay, does that make sense? And you'll see it if you do a few more and you have to graph them, you'll see that. So that's the statement right there. Always obtained by reflecting the graph over the y equals x line. Okay, so if we're given this graph and we want to sketch the inverse of it, we want to draw our y equals x line, which is just a diagonal line, 45-degree angle, if you want to think about it that way. Okay, so here's what we do. And let's also think a little bit about the ordered pairs. What is the ordered pair for that one? X is what and y is what?
1, 0, 1.
1, it's 1, 0, right? 1 to the left, or 1 to the right, I mean, and up 0. So what is the inverse going to be?
0, 1.
0, 1. It's going to be right up here. Notice it flips across this line. What about this one? It's going to be 2, 1. So when we reflect it, 1, 2. Notice we have a boundary kind of right here when x is 0. That means we're going to have a boundary right here when y equals 0 on the inverse. And so we can get the idea of what this is going to look like. Do we see that it's a reflection over that line? So once you get a couple of points flipped over, then you can just kind of copy the shape, but as a mirror image over that y equals x line. Okay? And you don't have to be a good artist, but does that make sense? Because believe me, I'm not. So, all right, we're done.
No way.
No way. Okay. So again, please make sure as far as your homework, get that done by midnight on Monday, Tuesday next week. Okay. The review, I put a due date on the review. I put a due time of 7 o'clock, just because I want you to have tried some things so that you have to, it's not graded. Okay, the review is not graded. That's for your practice to get ready for the test. There will not be any concavity on there, but pretty much everything else is going to be fair game. I'm not trying to kill anybody with this, so hopefully you don't feel like I am. I tried to make it reasonable questions, but also not just all super easy and not super hard either. So please try the review. And like I said at the beginning of class, for those of you who weren't here, I will answer some questions over review. But again, because you can generate all sorts of random questions, you don't just say, oh, I need to see number 5, because all of your number 5s are different. And so just bring me a specific problem and I'll go through it. Chances are, if you struggle with it, probably somebody else struggle with a similar kind of a question. Okay? That makes sense? So review next week, then we'll take our test, then we'll cover 2-1, and we'll get out.